Solids expand when they are heated through a change in temperature, delta theta. How much does the solid expand, delta L, or the change in length, delta L, depends on three factors. Depends on the linear expansivity alpha, the original length L naught, and the change in temperature. So if we start with a much greater initial length, we'll have a much greater expansion. And then if we have a much greater change in temperature, we'll have a much greater extension. And finally, the expansion of the solid, the linear expansivity of the solid, or the linear expansion, the linear change, depends on a constant known as the linear expansivity alpha of the material. Every material have, or different solids have different values of linear expansivity alpha. So for example, copper and iron will not expand the same. They will have different expansion for the same length and for the same temperature change because the materials are different. So they have different expansivity alpha. We can define the linear expansivity alpha as the change in length per unit length per degree rise in temperature. We can define the linear expansivity alpha as the change in length per unit length per degree rise in temperature. Mathematically, we can calculate the new length L2, which is given by L1 open bracket 1 plus alpha change in temperature, where we can define L2 as the new length at theta 2, that's the new temperature. L1 is the original length at initial temperature 1, theta 1, and alpha is the linear expansivity in per Kelvin or per Celsius. And delta theta is the rise in temperature, which can be calculated as the new temperature minus the final temperature minus the initial temperature.